Hello everyone, this is Mankumaru Upala of CSIT A section studying in Institute of Aeronautical Engineering. Today's my tech talk topic in data mining and knowledge discovery is a comprehensive analysis classification techniques for educational data mining. And let's go into the topic. A comprehensive analysis classification techniques for educational data mining. Introduction to Educational Data Mining (EDM). EDM applies data mining techniques to education data, and it helps understand student learning pattern, and it aims to enhance learning experience and institutional decision making. Key applications include predicting student performance, dropout rates, and personalizing learning. Importance of classification in EDM educational data mining helps predict student success for failure, and it identifies at risk students early, enables personalized learning paths, and supports automated grades and decision making. It also assists educators in designing better teaching strategies. Overview of classification techniques. Common classification techniques used in EDM: decision making tree (DT) and naive Bayes (NB), support vector mission (SVM), K nearest neighbors (KNN), artificial neural networks (ANN), and random forest (RF). These are the classification techniques used in EDM. And let's go to decision tree (DT). A tree-like model used for decision making works for splitting data into branches based on future values, and its advantages are easy to interpret and visualize and handle both categorical and numerical data. And the disadvantages are can overfit in not beyond properly, and it means it cannot overfit if not pruned properly. It means if the data is not in the properly arranged, it cannot be overfit, and it is a disadvantage. An example: predicting student pass or fail based on attendance and scores. It is a disadvantage. And now let's go to Naive Bayes (NB). Based on Bayes' theorem for probability calculation assumes that all all futures are independent, and the advantages of naive Bayes are works well for small data sets and computationally efficient, and the disadvantages are assumes independence, which may not always be valid. Example: classifying students into high achievers, average, and low achievers. And now let's go to support vector machine (SVM). It is a powerful classification algorithm using hyperplanes finds the optional boundary that separates classes, and its advantages are works well with high dimensional data and efficient for complex classification problems, and these disadvantages are computationally expensive for large data sets, and its example is identifying students needing academic support. And now let's go to K nearest neighbors (KNN). It classifies data points based on the K nearest neighbors and works by finding similarities between students. And its advantages are simple and easy to implement. and there is no training phase required for these k nearest neighbors. But the disadvantage of performs performance slow down for large data sets. It means if we insert large data sets, the performance will be very slow as if the data set is very large. So the disadvantage mainly is this. An example, grouping students based on the study. So if they group the students of a learning students, then the disadvantage for the average learning students will be more because they won't get the as what we say is as we compare to them we mostly take uh, learners like that. Artificial neural networks ANN uses interconnected layers for neurons to detect patterns and can model complex relationships in data. Advantages: high accuracy for large data sets, can adapt and improve learning over time, and disadvantages are requires large training data sets and computationally expensive. Example, predicting long-term student success. And here we can take a AI also, as it is a real time, it updates, and we have to train the data sets every month and every day as the new information goes into the background of the data of ChatGPT, and we need it requires large training data sets, so it is very expensive when we compare to other AI or artificial intelligence. Now let's go to random forest RF, and it's a combination of multiple decision trees and improves classification accuracy. Advantages are reduces risk for overfitting and works well with large data sets, and the disadvantages are can be computationally intensive. Example, predicting student dropout rates. And comparison of classification techniques. Decision 3, simple, interpretable, risk of overfitting. And let's go to naive base, first but assumes future independence. And SVM, good for complex data but slow for large data sets. And KNN, simple but insufficient of big data. ANN, high accuracy but needs large data sets. Random forest RF, more accuracy reduces overfitting. Applications of classification in EDM, educational data mining. Early warning systems detects at risk students and personalizes learning tailors study plans. Dropout prevention predicts students likely to leave. Course course recommendation suggests relevant courses to the students, and automated grading. AI driven evaluation in assignments. Challenges in classification for educational data mining. Data quality issues, incomplete or inconsistency student records, and it imbalanced data. Some categories have very few samples. Interpretability, difficult to explain complex models like ANN. Ethical concerns, student data privacy and security risk. Computational, some methods are very high to com, uh, compute. Future trends in educational data mining. Deep learning, enhancing accuracy with advanced models. Explainable AI, XAI, making AI driven decisions more transparent. Auto ML, automating model selection for easy of use, big data using large scale data sets for improved predictions, AI powered personalized education, adaptive learning based on student behavior. And the conclusion, classification in key to improving educational outcomes, various algorithms for different advantages and trade-offs. Choosing the right technique depends on the datasets and objective. Future advancements in AI with enhanced capabilities. Thank you. And this is Manikumar.